So in PureAir filtration, just a brief introduction. If you have had the pleasure of attending our previous webinars, some of the information about our history will, you've already seen this, but for our new webinar attendees, just wanted to introduce PureAir a little bit. We're located here in Atlanta, Georgia. It started off with me being here 13 years, and the company now is 16 years old, going on 17. Had the ability to watch the company grow to now starting off with maybe 2 or 3 employees, now over 30 employees, and really sales, all over the world. So definitely expanding our footprint, provide solutions worldwide. Some of the notable customers that some of the notable customers, whether it's Intel or ExxonMobil, even some industries where we're working with food companies or manufacturers such as Dannon, kind of shows the broad range of PureAir's capabilities as far as providing custom solutions. PureAir filtration, we currently, let's say we focus on 4 main areas for business. We have, I'll explain each area briefly, where we have odor control, odor environmental emission control. So typically municipal applications where you have a lot of sewage gases such as H2S, hydrogen sulfide, and VOCs. Provide systems to neutralize those different gases to provide clean air. So that's that's the majority of our business at the moment, is providing those odor control systems. Indoor air quality, typically, that's for airports, museums, kitchens. We're going to make sure we provide clean air, inside of those buildings. An example of museums where you want to protect precious artifacts from just standard airborne contaminants from humans as we breathe, or the emissions from our skin. You want to protect those, protect those precious artifacts. Just had the pleasure of visiting the National Archives last week, and we want to protect seeing the Constitution was pretty remarkable for a document that old and still be in place. And it's very important to have some type of air filtration, which they have, to keep that document preserved. Protection of mission critical electronics, very important, mainly at refineries or paper and pulp mills. Those same odorous gases are very corrosive, so they will damage and destroy expensive electronic equipment. So it's important to provide some type of system to keep those rooms clean. And today we're going to talk about emergency gas scrubbers or toxic gas scrubbers. I would like to mention that PureAir, we're venturing into some new arenas for filtration. One being biogas applications. We're still working to design and develop some systems and technologies for biogas, as well as antiviral technologies. Because as of course, we're all experiencing the pain of this pandemic of COVID. So we are working on some solutions to provide some protection. I noticed that there was someone raised their hand, so I would definitely get a chance to answer any questions soon after the webinar. If one of our panelists also, if there's an easy enough question, they may be able to respond as well. So, but with that, we'll move on. So, why are toxic gas scrubbers needed? Really, I would say for me, the 3 main, reasons or functions for the gas scrubber is that we want to provide protection for the neighboring community and neighborhoods in case there's any accidental toxic gas release, which is very important. If you have there's a water plant situated near a neighborhood, you want to have some type of protection in case there's a release, because you don't want, the last thing you want is any loss of life. So it's very important to have some type of system. I've seen quite a few sites where the neighboring houses may have been 100 yards away. So very important to have some type of protection. And you also want to protect the site personnel from the toxic gases as well. So, the workers that are, changing out the different, working in the plant, changing out the different cylinders of toxic gas, making sure everything is running properly, making sure the water is being disinfected for our use. We want to make sure they're protected in case of a release, so there's not, stuck in the building with toxic gas around them. And also, you want to protect the systems and the electronic equipment from the toxic gas. And I mentioned chlorine here in this particular slide, but it's a very corrosive gas, so it will, cause great damage there, which can be very expensive. And also, one of the benefits, not as critical as the 3 in my opinion, but it's also has its important in its own right as far as the risk management. So in most cases at water plants, the EPA here in the United States will require you have some extensive documentation, if you're using a lot of these toxic gases. Well, if you have a scrubber in place, there's a good chance that you can reduce some of that paperwork. So that's usually a good help if you can do that. That way, filling out paperwork is not very efficient and it's time consuming. So if you can, lessen that, you can, help us be a little more productive. Some of the common gases that we see in the water industry that we focus on: sulfur dioxide, chlorine, and ammonia. Chlorine being the most common that I see. It was sulfur dioxide a close second. Ammonia scrubbers, we don't see it as much as far as for a toxic gas scrubber, but it still is a common gas in the water industry. So some of the risk factors that we consider when, I'll say mainly when we're determining if a scrubber is needed, and also the size of the scrubber. So you have the amount of gas stored, at the facility, which is very important. Again, per the different codes here in the United States, if you decide to provide a scrubber, you only need a scrubber for the largest cylinder or container of that particular gas on site. So the scrubber, so for example, you have 1-ton cylinders that you're using for toxic gas, you're only required to provide a scrubber that can handle just one of those cylinders as a safety precaution. In some cases, some customers have size for 2 or 3, but you're only required to have 1. That's important to let us know what size system is going to be best for the protection of the end user and customer. Location of personnel in public, very important, as I mentioned previously. There's any neighborhoods or neighboring houses around the plant, it's important to make sure you have that scrubber ready and on standby just in case there's an accident or release, as well as personnel. Are they located in an area in the plant where they can isolate in case there was a leak from the wherever the toxic gas cylinders are located. In some cases, it's possible they're in the same area and they don't have the ability to kind of shelter from that. The geography of the surrounding area, very important. I was once told, it was a project, and it was in Colorado. They were looking at a scrubber, potentially, but it was a remote area. So they mentioned, they're not looking to provide a scrubber at the moment because one thing in that area was prairie dogs. So they weren't too concerned with that. I didn't think that was a very, very nice thing to say, but I understood. So, but as urban encroachment happens and the homes start to be built around these plants, and then the need may arise. And also the abilities of the local hazmat teams to arrive on the site. So in the unfortunate event that there is a release or accidental release of this toxic gas, you know, how fast can the first responders arrive to contain that? So that's important. Scrubber in place, you know, that buys them quite a bit of time. At least of the size for one of the containers. Multiple containers burst, well, it's going to be a problem, but at least buys them some time to arrive. And also facility construction, and I'll talk about that a little bit more. But sometimes older buildings don't seal up as well, so you may require a little more airflow to ensure we're getting that vacuum to suck out the toxic gas. So critical area characteristics, so area volume. I'll discuss a little bit later, kind of like the airflows that we see, kind of minimum airflows for scrubbers. But with that said, you know, we have that minimum, but there's really no maximum airflow. It really just depends on the area or the area volume of the room. And as long as we're providing that vacuum to remove the toxic gas, you know, we should be okay. So if you have a large area, you may require more airflow, of course. Structural conditions, you know, again, is it an older building? Is it airtight? Are there any openings, windows that aren't quite sealed, or any dampers? It's very important, because when we're pulling that vacuum, we want to make sure that, you know, the building is older and, you know, things aren't as tight. Just need to provide that much more airflow to overcome that, so we can still achieve that proper vacuum. It's really just a slight vacuum. Entering and exiting of operators. I've seen it quite a few times where, you know, operators go in and out of the chlorine room, and some projects where, you know, they will require that the scrubber turn on every time the doors open. So that's not as common, but I have seen it. So, you know, just as that layer of protection in case there's a release or accident while there's operators in the building. But as they're opening and exiting, entering and exiting the room, it does, you know, create potential for loss of that vacuum. And the room walls, they're going to be exposed to corrosive gas possibly, so want to make sure they're designed to withstand that, so they don't deteriorate during an event. And also location in the facility of the basically mainly the contamination source. So if the toxic gas cylinders are located further away from where the scrubber is located, you just have to make sure that the pressure drop that's going to, an external pressure drop in the ductwork from the cylinder room to the scrubber is accounted for. That way that the blower can be sized properly. Make sure to overcome that external static pressure as well as the pressure within the scrubber itself. So two different types of air scrubbing technologies I'm going to talk about. Dry scrubbing, and that's the use of using a dry solid adsorbent media to remove the gas. I will talk about that a little more in depth here shortly, but as basically how that works, as the corrosive air or the toxic air passes through the bed of media, it's going to be captured inside that media, so which is going to neutralize it to ensure we're getting out clean air. Wet scrubbers, same general function where we're drawing in the toxic air, but it uses like a liquid in the form of mist to neutralize the gas, the different toxic gas. So inside of that wet scrubber, there is like a inert medium that the liquid adheres to, and so that liquid is sprayed over that medium, and that's what's used to neutralize the toxic gas. Dry scrubber components, very simple. Just have a vessel, adsorbent media, and the blower. Of course, there may be some ancillary items like chlorine sensors on the exhaust stack, so on and so forth. But in general, just have three main components for the dry system. So here in this diagram, you guys see my pointer, that typically with, in this particular instance, a cylindrical style scrubber, the flow is top down. So I'll kind of explain that a little later on why we design it that way. But as the toxic gas comes in through the system, neutralized in the media section, then it's exhausted out, it's pure clean air, and through the blower section. Here's the same system, same setup, except it's just in a horizontal configuration. So the air enters through here, this inlet, it goes is the plenum section, and then these sections here contain the media that's used to neutralize the different gases. And then another plenum section, and then exhausted out, clean air. Wet scrubbers almost has more than double the components required. So you have the vessel, of course, but you also need pumps and different pumps, valves, and nozzles to actually pump the caustic liquid onto the medium. And you still have the blower and the caustic liquid holding tanks. So a lot more to maintain on a wet scrubber. And I'll discuss a little bit later, some of the, pros and cons of both. To be a little biased, dry scrubbers are, in my opinion, the best way to go for most applications. For example, okay, so wet scrubbers, they have a lower initial cost and they have the lowest cost for release. But you have to make sure you size it for the worst case scenario. So in essence, if you have a small release of a toxic gas and the wet scrubber is activated, well, the issue is that caustic material is going to lose some of its capacity. So, but there's really no way of knowing how much of the capacity was lost. As it reacted, it started to mix and lose some of its capacity. So it's possible you may have to replace all of the caustic media, even if it was just the caustic liquid, even if it was just a small release. So that's something to keep in mind on that. And also over time, that caustic material is very corrosive. It will eat away at the pumps and the valves and all the nozzles, over time. And it's so that has to be, you have to factor in that when you're doing a life cycle analysis. How often will you need to replace the valves and the pumps? And caustic material itself has a shelf life. So every 5 years, you have to replace all of that caustic and put new caustic in. And it is a very hazardous chemical. It's they say they call it, it gives you the burn that you don't feel. So as you're working with it, or even if you have on the hazmat suits, if any drop of the caustic gets on your skin, it'll start to burn you immediately. And you just look down, you have all these burn marks. So very, very unpleasant for maintenance and the maintenance required to change out the wet scrubbers. Now, in dry scrubbers, very low maintenance. They cost a little more than the wet scrubbers, just because of the systems tend to be a little larger, and the adsorbent media has a little higher price than caustic. But that media will last indefinitely. So that means in a dry scrubber, if it doesn't come in contact with any toxic gas, that media will last years. We have seen systems in place 10 plus years with still showing 100% media life. So that really helps. And also for the maintenance, very simple. Those systems just require running follow any maintenance on the blower, of course, lubrication schedules from the manufacturer, but also just turn on the unit once a month just to exercise the belts, just to keep that blower moving. So we even recommend that, once when you're changing out, when the customers or personnel are changing out the cylinders, turn on the blower, turn on the unit. So that'll offer two functions. It'll exercise the blower and also provide safety for the personnel. All right. Here, I just wanted to show the slide of some of the corrosion that takes place, specifically caustic corrosion. So kind of shows that it will eat away at all the valves, the pumps, and the nozzles. So very big undertaking for that. All right. So if you are familiar with our webinars, you have seen this slide, and this is our PureAir model, and we actually we believe these words. So it's more than the motto, but it's the truth. So we are the world leaders in removal of gases, odors, and vapors. So how do we do that? Through gas phase filtration technology. So what is gas phase? Multiple names for chemical filtration or airborne molecular filtration or gas absorption. So what we're doing is we're removing contaminants that are very small, really smaller than a dust particle, so really in the molecules. So we're capturing those different, harmful and odorous gases before they enter the atmosphere or a populated space. So some of the sizes, kind of give you an idea of the size of some different particles. So like solids, for example, you have 0.03 to 100 microns, and that would be something similar to like smoke or dust. And also liquids, 1 to 9 microns in the form of vapors or in the aerosols. So typically, you can remove the solids and liquids using more of a mechanical filtration. And that would be for example, a dust filter, similar to a furnace filter, or some type of bag filter, or even a mist and grease filter for the liquids and vapors. But with gases, with them being so small, we have the 0.0003 to 0.007 microns. The mechanical filter won't capture that. It'll pass right through it. So that's where you would need some type of other medium to capture those gases. So, absorption, adsorption. With our systems, our technology, we're focused more on adsorption. I won't really get into too much with the absorption, but with the adsorption, that's the best way to describe that would be a sponge. So you have a pool of water and you drop a sponge onto it. It's going to soak that water up, and it's going to capture it inside and hold it in place. That's the same with the different dry medias that are used for gas removal. So you're going to have that media is very porous, and I have a slide that'll show that shortly. Very porous. So as those small molecules travel over the media, they're trapped inside, held in place. Now, when you're dealing with just adsorption, there's a possibility for that gas to desorb, similar to a sponge. So if a sponge full of water, you squeeze that sponge, the water is going to come right out. So the same with the medias. So either different ways for that to happen. So you have that once the gases are trapped inside of the media itself, if larger molecules come in the airstream, they could dislodge the molecule that was there, and that molecule passes through and out through the system. They call that off-gassing or desorbing. And also, there's also ways to reactivate those different medias as well by using some type of regeneration process to wash out the different molecules. So, that's adsorption in a nutshell. Now, chemisorption is really a form of adsorption, but now that media is impregnated with some type of catalyst and to react with the gas. So, in that way, there's no chance for that gas to desorb. So once it's captured, that's it. It's not coming out. So, also mentioned on adsorption, with that desorbing, some of the efficiency can be affected if that happens. I wanted to mention that. All right. On this slide, as I've already talked about particulate filtration versus gas phase and the different sizes of the molecules, removing the molecules from the air, I wanted to direct your attention to this diagram here in the upper right-hand corner. Really just kind of a general, I'll say general, but very effective diagram just showing how our systems work as far as gas phase. So in essence, if you just imagine that this entire box here is a media bed filled with whatever media to remove the gas, you have the contaminated air coming in this way. So we have spent media here, and here, this section here, this thin section it's called the active transfer zone or the working zone. So that's what is really doing all the work to remove the different gases. So, and this is important for our systems because it allows us to monitor the remaining media life in the unit, which is we can do that manually or remotely. So, using technology, today's technology, is making it very beneficial. So again, we have the contaminated air coming through. This is the spent media already used up. This is the media that's working, and we still have unused media here. So as that working active transfer zone is just making its way through the media bed, and we're exhausting out pure air. Once that media is used up, it has to be replaced. And the picture here is just a general drawing or diagram of a type of scrubber system that's used just to hold the media itself. As one of our representatives kindly put it, he said, it's just the box that holds the kitty litter. I'm like, well, that's somewhat accurate, but it works a little better than kitty litter. So how does the dry scrubbing work? We're passing the air through the adsorbent media pellets, as I mentioned previously. So that media is going to capture those gases in the pores, and it's going to convert that over the media. I guess the media and the gas will convert to a harmless solid byproduct, and we're exiting out pure air. So some of the different configurations for the dry scrubbers, depending on the size of the container of the toxic gas on site, as I mentioned previously, that'll determine the type of unit. The unit here is sized for 150-pound overfill cylinders or 75 kilograms. And the unit here below is the size for overfill 1-ton cylinder, metric ton cylinder of chlorine gas. So really just depends on the amount of gas and also the footprint, or if there's any restrictions, site restrictions, space restrictions, kind of give us a better idea on how to size the system to work properly. And also materials constructions. Typically these units are constructed of fiberglass, as fiberglass has the highest chemical resistance to chlorine. It's a much better material of construction than most materials. Interior installations. So again, you have just the same configuration: vessel, media is inside, blower, but this particular unit was indoors. So that's some of the benefits of the dry systems, that you can make them into more tight, compact spaces. Versus if you're looking at a wet scrubber, will take much more of a footprint, much more of an area. Exterior installations, of course, same setup, but a little different, a little taller than the one indoors, but still the same design. Top down, the contaminated air comes from the top down to the media bed, clean air out through the stacks. And also difficult installations where sometimes it's necessary to provide the system in pieces to load into a building or a basement. Much easier if their units are located outside, because they're designed to function properly in harsh conditions outdoors as far as temperatures. So that's not a problem. But in some cases, if it's required and the customer wants to keep the scrubber under, hidden or inside of a building for security reasons, and then that can be done. It's a little more design criteria goes into that, but it can be done. So different configurations for the systems, whether it's typically two different configurations, vertical or horizontal flow. And really it comes down to, I would say, end user or customer preference as far as, what type of system they would like the design to follow. From our experience, the horizontal flow systems are a superior design, or more advantageous design, because of the lower profile. Particularly, those units are only about 7 feet tall, which is approximately a little more than 2 meters. So not very tall, and they can also fit into an ocean container. So it's easy to transport, and for us to transport worldwide. Because as I mentioned, PureAir filtration, we provide systems all over the world. So, well, with using these horizontal flow systems, we're able to ship those systems anywhere and provide that protection. With the vertical systems, they can also be shipped as well, but a little more difficult and a little more costly, a little more cost to that as well. So types of dry filtration media. Physical process, we're really not, for this particular webinar, it's not as important, but I still will mention it. Talking about the adsorption, where it's the activated carbons, typically, and it's a reversible process, as I mentioned, that those medias and carbons can be reactivated, whether using water or heat to burn off the different molecules and contaminants, and then reuse that carbon. It loses some of its capacity, but you can reuse that. The chemical process, so adsorption or chemisorption, that particular media is impregnated with some type of, I would say, catalyst, and that's what's going to react with the gas. So what happens, you'll get that gas reacts with the media, and then you're going to have in essence, a solid byproduct that is irreversible. So once that media is used up, there's no regenerating. It has to be replaced. All right, fundamental function of chemisorption. I guess I kind of got ahead of myself a little bit, but again, like I said, that media is impregnated with some type of catalyst. That process is irreversible. So once it's spent, you have to replace it. But it is that reaction turns that media and the gas into a solid, and it's a harmless solid. So it can be disposed of in any other ordinary ways through any landfill. I just recommend that you check with your local codes before disposing. So filtration, how do we select the media? So first, as long as we know what type of gas that's present, that will allow us to provide the proper media. And as far as the airflows as well, and what other concentration data that may be present. Now, for toxic gas scrubbers, that's not as important because we're mainly sizing the units to handle a full container of that particular gas. So that gas is pure. So it's designed to neutralize all of that particular gas. But I will say it's very important that the media is non-flammable, because the adsorption process, chemisorption process, will create heat. So it is extremely important that the media used is non-flammable. As an example, we're talking chlorine. Chlorine and carbon are not compatible. So they will potentially cause fires. So, there are some providers out there that use carbon in their substrate for their different toxic gas medias, and if they're using for chlorine, that can be very detrimental. There was an issue in Tennessee a few years ago where the media, they had a chlorine leak at the plant, and the media started to catch on fire because that media has some carbon in the substrate. So it was be very detrimental, where not only you have a chlorine leak, but you're also losing the vessel itself. So now you have no protection. So very important that media is non-flammable. Here's a slide. This is kind of showing like a microscopic view of the media itself. As I mentioned previously, it's very porous. And this slide shows you, this is actually activated carbon, but the media for toxic gas removals that we use, activated aluminas, also very porous as well. So, so it's great to capture those different molecules and hold them in place and neutralize them with the impregnate that's inside of the pellet. And the reason why these medias work really well because the surface area for that gas removal is it's very high. Some of the different adsorbent medias that we manufacture, Safetysorbs, we use that for removal of chlorine, fluorine, and also other halides. Carbsorb, so removing SO2, and ammoniazorb for ammonia and other amine gases. Safetysorb has the highest capacity for chlorine removal, about 15% by weight. So you're able to keep those vessels at a great size, smaller, smallest possible size, and keep that footprint, very, very reasonable. And it's also non-toxic. So even when you can put that in your hand, no worries about it burning you like caustic. But also when it's expired, you can landfill it in this landfill disposal. And it's also stable, has an indefinite shelf life. So unlike caustic, where the media every 5 years, you're probably changing that media out, going through that process. With the Safetysorb media, really, unless it comes in contact with large amounts of chlorine, like pounds of chlorine, that media will last indefinitely, has an indefinite shelf life. So it's even beneficial. Some customers even store a spare set of media in place in case they have a release or they have a backup to replace that. The only requirement for Safetysorb is do not let it get wet. The water will wash away the impregnate. So that's important. So you can keep it in a place indoors. It'll last quite a while. And it is non-flammable, has a UL class 1, level 1 fire rating. So why is UL important? So it's for the safety of the surrounding personnel and also the proper functioning of the equipment. Because that media, when it reacts with chlorine, it's an exothermic reaction. So you'd be in the form of steam, but it's going to heat up quite a bit. So you want that media. So you want a media that won't have the potential for catching fire. Example, as I mentioned, with carbon, media has any carbon in it. You have that potential for those bed fires. For the engineered absorbents, so as I mentioned, some of the substrates for these medias, for the toxic gas scrubbers, mainly chlorine, we're looking at alumina. Some of the other gases, whether it's if you want to eliminate SO2 or ammonia, we do use some of the activated carbons, impregnated activated carbons for those. Or in some cases, we'll blend it with the alumina. It really depends on the application and, for that. But in some cases, zeolites and clays, just some of the different substrates that we use just for any medias here at PureAir. And different impregnates really depends on, what gases are present and what we need to remove. So the design steps to meet UFC or the Uniform Fire Code. So this is design. This is basically, if there's, for any reason, there's a release or accidental release of the toxic gas. They say, for example, a 1-ton cylinder, overfilled cylinder of the toxic gas. So if there's the release in that first minute, you're going to have about 400 pounds or 181 kilograms of that gas from that cylinder is going to release in that first minute. Then after that, the first minute, it's about 80 pounds a minute or so. So you want to ensure that you have a scrubber that's going to overcome that initial burst of the chlorine gas. So typically, it's been calculated that first minute, that 400 pounds per minute, the volumetric flow rate coming from that cylinder is about 2,100 CFM. So you need a scrubber that's going to overcome that 2,100 CFM. So we always say the minimum airflow for a 1-ton system is about 3,000 CFM. You want to make sure that you're well above that 2100. And now in some cases, for our systems, we typically size them 5,000 CFM. Just gives us that added benefit. I've worked on projects where they wouldn't needed 10,000 CFM because it was a very large room. And they want to make sure they pull enough vacuum, just a slight vacuum, to ensure that the chlorine gas is passing through the system itself. So a lot of design features and calculations that we use to determine the airflow. Biggest, velocity through we can make those systems as big as possible, as big as we need, but as long as we're keeping the velocity through the media itself around 100 feet per minute, no more than that, and that gives us an idea of how to size the system. And also, choosing horizontal or vertical flow, which we are fans of the horizontal system for a multitude of reasons. So as I mentioned previously, monitoring existing bed life. Here we offer a service where for the life of a scrubber, we recommend that the plant personnel take samples of media once a year and send them to us, and we'll test it free of charge and send a report back that indicates how much media life's remaining, which is it's a great function, but it takes time. So you have to first grab the samples, then ship them to PureAir, and we'll test them. We usually turn them around pretty fast, and then we send the report out. Well, if you're across country, it may take a little time to get those results, maybe a week or two. Well, with we developed a electronic media bed monitoring device that allows the personnel to monitor the media life at real time. So it's this bed monitor actually has a rod that is inserted into the media bed, and it has sacrificial sensors on it. But each one of those sensors are let's say not corroded, but they react with the media. It sends that signal back to the control box, and from there, we can send that 4 to 20 milliamp signal or Modbus, or be all cloud-based, to determine the remaining media life. So once these systems are set up in place for that to start up, we have anticipated life, of course. With these systems, they're in standby, of course, but it's all set up and calibrated so you can have that reading, back, to the plant personnel, whether it's tied into the building maintenance systems, and we can also monitor the life as well from PureAir. So if you have any small releases, we can keep track of that, keep track of the media life. So very proud of the of this accomplishment, and with technology, it just allows us to come up with better ways to serve the customers. So, and with that said, are there any questions? I will look to see. See no open questions at the moment. Let's see if I'm looking in the right place. Oh, let me go to the chat. Okay. All right, okay, no questions so far. I think there might have been one question, but it was answered, so. Anyone have any? Oh, so this is a question from Jamie Escobar. She said, where do you place the monitoring rod? So actually that rod is installed in the, it's in the media bed itself. So it's installed at a 45-degree angle along the media bed, along that direction of airflow. So we'll install that in the media bed sections. So as those sections are used up, and those sections are, actually, I'll make sure I'm answering the question. This is also for Jamie Escobar. I think I just hit making sure you heard my response. but that media bed monitoring rod is placed in the media bed sections. So it's just going to measure that progression of media usage. So we'll design the systems to accommodate the rod itself. And it can also be retrofit on existing systems as well. So that's something down the road if you decide to, you want to install the system. If you have an existing system, that can be done as well. Give you that added feature, added protection benefit. Did that answer your question, Jamie Escobar? Okay. How about see another question from Daniel Rodriguez? I think it may have been answered. It was, can we apply this technology for dust control in confined spaces in the, I guess I'm gonna say, mining industry? So yeah, we provided systems for different mines. So yeah, gas phase would work. We just have to take a look at the application, and if we have any any data that you can share with us, we can definitely take a look at it and see what we can do. I will say that, at PureAir, we pride ourselves on providing custom solutions. So really, there's no project that's too daunting for us. We can figure something out. And if we can't, we can offer some suggestions. All right. Any other questions? Well, I must have did a good job of explaining. No questions. Okay. But I believe this, what is the criteria? Okay, another question from Jamie Escobar. So what is the criteria to replace the media? 100% used, 75% used? I will say, 100% used for sure. You definitely want to replace the media. 75% used, we would recommend, once we took the sample and it's verified on the electronic bed monitor and we sample it and it's verified, then we can just replace the media, just whatever section that's used up. As I mentioned previously, we have that system, the design is top down, or if we're using a horizontal flow system and where the media is in chambers, it's possible that only one chamber media is used up. So we can just replace that chamber only, and we can confirm if the other chambers still have 100% life. Because we have sample ports all along the media bed, and I didn't show that. I didn't highlight that in one of the slides. I apologize. But there are sample ports along the media bed, so we recommend taking samples from each port. That way we can gauge and see where we need to replace the media. But also I want to mention that, we offer also like an insurance policy. So in case there's 50% media used, we'll replace that at no additional charge if that's needed. Yeah. So Kevin kind of responded as well. So. A lot less long-winded than my response. Okay. All right, so another question from Jamie Escobar. So if you have, please answer this live. So I have another question from Jamie Escobar. So I said, if you have chlorine media in the shelf, but you have H2S in the plant and exposed to the media, that will affect it, question mark. Great question, Jamie. And actually, no. With the chlorine media, the Safetysorb, it is only looking for chlorine. It will not react with any other gas or any other, well, not H2S, maybe different halides, but it's not going to react with H2S. So you can pass H2S through that media all you want. It will not affect it at all. But great question, Jamie. All right. Any other questions? Let's see, make sure I don't leave any questions open. All right. Okay, another question from Jamie Escobar. Who are our major competitors, and what do you suggest to use against them with our consultant engineers and or end users? Oh, that's a fantastic question. So for toxic gas scrubbers, say the main competitor, well, you have two. A company called PureAir and also Denora. They used to be Severn Trent. So they're our main two competitors. PureAir, you know, let me make sure I answer live. So PureAir, they use carbon in their media, so for their chlorine systems. So that's a big no-no. So they have the potential for bed fires. And the unit that I mentioned previously in Tennessee was their unit. So that was a disaster. So I would say as long as you are, imploring the end users to make sure they're using the media that does not have carbon in the substrate, that is an advantage for us. Denora, they actually have a media that does not have carbon, so that will not work with them as much. But also very important to implore the end user to provide an electronic or require electronic media bed monitoring. So that's a fantastic tool for the customers, end users, to determine remaining media life to ensure that you have a system that's at 100% ready. So, that I would recommend making sure that that is in the specifications for that electronic bed monitor, and then that will work for you. Work for all. Oh, okay. So sorry, this question about the media, about the competitors were from Dick Balzarini of Dorian Drake. So not Jamie Escobar, but okay. Well, no problem, Dick. Thank you for the great question. Any other questions? Well, with that said, I will say thank you everyone for attending the webinar. Thank you very much for the great questions and also for your time today. Oh, another question, is there a difference in efficiency between the vertical and the horizontal systems? No, same efficiency. Same efficiency, just different configuration. But it's easier to ship the horizontal systems worldwide, but same efficiency. All right, with that said, guys, thank you very much. If we can provide any other service or answer any questions, please feel free to reach out to us. I believe that this webinar will be made available, link sent out to view it in the future here very shortly.